Okay, so we're just gonna try to stream, and even though our connection completely sucks, we're just gonna try to do something here. Um, so let's go here. Let's go find the project we made, and also we wanna sync the project with our actual this thing right here. This is on my repo drive. I need to pull down what I just pushed up to GitHub from here. So let's do a git status and git pull GitHub. Actually, I don't know what that is. Git remote dash v. Where are my remotes? Yeah, git pull and GitHub master. And we're pulling down the changes we just pushed up from the thumb drive. And then we're going to take a look at what we have. And also, technically the category now is... technically the category is not science and technology. Right now it's... right now it's more like making and crafting than it is code right now. But yeah, let's go take a look at those models we made for the laser cutter. So, oh, also, hold on. We pulled those down, but we have those changes we want to merge. We want to do a git add dot, git status, git summaries and things. Okay, so we're going to push up those changes, and then we want to update our shop summary. So we cut 72 pieces, which translates to 36 parts, I believe. Because 35 and 35 is 70, yeah. So let's go look at that and go into the shop summary, and we have a by month summary. We're not going to do anything in the by day summary unless we have something that's actually interesting for that day. Otherwise, we just want to not... we don't want to clutter... where'd you go? Okay, you're over here. We don't want to clutter this by month... We don't want to clutter our summary files with inconsequential things. Right, we actually want it to be, when we're going through these summaries later, we want to be able to find what we're looking for easily. So if we didn't do anything eventful on a certain day, we're not going to make a specific shop summary file for that exact day. We'll only add to the monthly summary on that day if there's nothing really that eventful. So there wasn't anything eventful happening today, but we just cut some more parts, right? So on the... So, also... let's just say, you know, we missed this day. I'd like not to miss days, but let's make it kind of obvious when we miss a day, just because that way, when I'm like, why don't I have all the parts I want? Well, it's because I missed a day. So this is the reason, right? So I missed a day. The reason was mom needed drugs. And so now we have, on the 20th, today is the 20th, and we cut 36 parts of the black, right? So 36 black, and then everything else is not cut, right? So just 36 of the black, and that's all we got. So over here, that means we didn't cut anything here, so it's like, I don't know why I'm making tables like this, but sometimes to find the best way to like organize stuff, you have to just start somewhere, right? You gotta take an approach to how you want to organize things, and then as you work on that, you might find, you know what, this approach isn't working. So now that you have this 36, right, in the total here, this total here, these are the coffee table parts. And did we put everything in here? All the parts? It looks like we did, right? So, because 72 and... yeah. So let's... oh. Oh, hey, sorry. Sorry, just, okay. So, yeah, I was just at the shop earlier today. I'm just making a summary list of what's going on here. And I was over here because I was just going to open up, so 36 times 3, and then adding 12, 108, 108 plus 12. Okay, 120. Oh, these are the number of, oh, I see. Okay. So this is, 120. Okay, so these are my totals, and these are, number amounts needed for different models. So, to make coffee table. I don't know how I'm going to organize this. Let's just keep it like this. So these are the totals, the current totals I have. This is the total amounts that of each kind of part that I need to make a coffee table. So right now we're at 120, which means that we have enough parts in total, but that's the number of parts of just all colors. So in terms of black, if we want to make something black, so these totals, really, just get rid of these totals. These totals aren't very helpful. This total isn't very helpful, because we're going to make everything kind of a solid color here. Yeah, we're going to make everything a solid color here, so 36 and 36 plus 12, right? So 60, 70, 80, and then 84. 84, I believe. So let's look at that. We got 12 plus 36 plus 36, and that should be 84. I don't trust myself to do math, but I'm trying to always, calculate it in my head first before I pump it into a calculator. So yeah, 84 pieces. So this total is now at 84. And we don't really need this summary. We don't really need the summary of all the pieces we need for a coffee table, like on each one of these lines, do we? I don't think we do. I guess the idea of how I wrote this is, so total black, right? So total black is 84 right now. So we're doing this as a percent. Oh, I see. So I'm going to rename these columns. So this total here is total clear. I see what I was doing yesterday. So the total amount of clear. And let's just, I don't know. make these more distinct sections, maybe. Yeah. And total. My focus isn't at what it should be right now. Total clear. Actually, this is total blue. And this is total clear. Okay, so I see what I'm doing. Right, I have these different totals: total black, total blue, and total clear. And then I repeat how many parts I need for a coffee table in each one of these. So when I'm looking at my totals, I can see like how close am I to getting all the parts that I require for a model, or how close am I to fulfilling all the criteria, right, for making one of these things that I need to make, right? So right now, for the coffee table, we've been mostly cutting black parts, so we're going to try to make one coffee table that's black first, because that's the parts we've been mainly cutting. And we can see we're 84 out of 112 for the two ways, and then we got 0 for all these other things. Okay, so I'm just collecting my thoughts here, making sure that I know what the heck I'm doing here. And we're just going to... I don't know if we're going to keep this like a yearly list or how we're going to do this. But I want to keep like a ledger, right? So like when I create a coffee table and I like sell it, I want to like subtract from this ledger or something. And maybe I should be using like a CSV file or a code file or something to store this data. But the idea is that I don't want to get too complicated with my ledgers right out of the gate, because chances are things will change in my work process, and once my work process has cemented, I'll formalize these into maybe some type of code file of some sort. Okay, so now that we have that, and we know where we currently are, we're at 84 for this. Let's close this, and let's actually look at the file we were working on. So let's close this. This is the backup file. Let's go to the UPAT folder and look at what we were working on, well, at the shop. So it's called duct tape box. Let's open that up, and let's open this with, choose another app. We should have like an OpenSCAD somewhere here. Yeah, OpenSCAD.exe. Let's just put this on my right side of my screen or something. Okay. Okay, cool. So this is a very basic design, and it's basically going to be a wood crate that we can use in lieu of cardboard, right? So instead of transporting with cardboard and trying to find filler materials, I'm thinking, hey, let's just make a crate out of wood and just duct tape it together. And I had some other designs that were designed to be bolted together. But the problem with bolts, if you bolt something together, is that now the bolts are sticking out. And now you went through all this trouble of making this nice container, but now you still have to put it in a box because it has these bolts sticking out. So the idea is to create a proper box, right, that just has, what, 6 sides? 6 sides to cube? 1, 2, 3, 4, 5, 6, right? 3 axes and a back and front to each axis, right? So 6 sides. Just make a simple box that we can ship. And we don't need any packing materials because the wood is going to be like absorbing the impact. And we don't need any bolts to bolt it together or any glue because we're just going to assemble it, and then we're going to wrap it in a healthy dose of duct tape. So the thought here is that we're not going to skimp on quality, right? Now, that could be a problem where you know, if we don't skip on quality, right, we make less profit, right? Because we're going to... Yeah, bolts can get messy, yeah. I can show you that design. I can show you that design. Let me go show you that design later. But yeah, I don't know if you can understand this. It's pretty simple, all right? This is a cutout. This is a cutout for 1/4 thick plywood, right? And we cut this pattern here. And we cut this pattern here twice, and then we cut this pattern on the top 4 times. We're actually going to make a 3D model of this right now, right? So we're going to take this, and we're going to modify the code to make a 3D model from these blueprints. So the first thing is, I have too many text editors open. But oh well. Yep, duct tape solves everything. So let's open up the blueprints. Or not the blueprints, but let's open up that file. So in my models folder, we have the duct tape box. Right? I'm just calling it a duct tape box, right? So duct tape box, and the namespace is DTB. And let's open this up. And right, so in the code, in the comments, I'm already kind of like figuring out material cost, right? So if you're trying to make one of these boxes, right, I know that at Home Depot I can get like a 4-foot by 2-foot for like $15, and I can then subdivide it into these 2-foot by 1-foot sections. And each one of these 2-foot by 1-foot sections is enough to make the top and bottom of the crate. So if I make the sides of the crate with like scrap acrylic, we could get down to, you know, $3.75 per crate, right? So it's not a cheap way to send things, right? So but the idea is that if I want to think about how to differentiate myself when I'm selling something, and I want to also I also don't want to do the whole race to the bottom thing. Like sometimes people like make their prices lower and lower and lower, and then the competition gets ruthless and everyone's racing to the bottom in terms of their profit margins. So I'd like to try to compete in a different way, where it's just like I have something of a very nice quality, right? Where like when people look at the listing, a lot of times when you look at a listing, you don't really have a feel for what you're actually getting, right? Like if I try to buy acrylic squares on like Amazon or Etsy or whatever, I can kind of see like screenshots of the material, and sometimes you only get like one screenshot. But I actually want to do my listing where I screenshot not just the material, but I also screenshot how it's going to end up being sent to you, right? So when people see it, they're like, oh, it's coming in a nice sturdy crate, etc. But yeah, so I'm thinking, you know, can we sell 3 sheets and a scrap sheet for $25? Or can we go up to 50 because it's in an awesome crate? Awesome crate. Like, you know, because the perception of quality is a little bit higher when you put it in a very nice package. Like what can we do and actually reasonably do, right? So we have a limited amount of product, right? So as long as we can push product, it's going to be advantageous for us to sell at a higher price because we have a limited amount of product, right? Supply and demand. And also you have to think that selling 2 things for $25 is not the same thing as selling 1 thing for $50. Because, I mean, there's a lot of variables, but one of them is work, right? So if I sell 2 things for $25, that means I have to go to the post office twice. If I sell 1 thing for $50, I only have to go to the post office once, right? And you could take that to an absurd limit and say, you know, you could sell 100 things for 25 cents and have to, like, individually wrap and mail 100 things, right? Or you could, instead of selling those 100 things for 25 cents, you could just sell 1 big thing for... what, $250? Did I get that? Did I move the decimal the right amount of times? Hold on. So we got 25. We got 25 cents. And if we move the decimal, if we sell 10 of them, we gotta move the decimal over here. Oh god, can't do math. So we gotta move the decimal over here if we're doing 10 of them, and then we gotta move the decimal one more time. Is my decimal's on the wrong side. What am I doing? God, I can't do math. Okay, so 0.25. Okay, wrong way to move the decimal. Okay, so if we sell 10 of them, if we sell... Okay, yes. So 100 things for 25 cents, or you could sell one thing for $25. So I had that math correct, but I just wanted to think it through to make sure I had it right. So that would be an absurd example, right? Like, it would take a lot of effort to sell 25 little knickknacks. It would be better just to sell one big thing that you can sell for $25. So we only have a limited amount of material, right? So if we can sell for the higher price, we want to go for that higher price, right? If no one bites, if no one buys anything at all, then we're not going to sell for the higher price. Also, like, let's say people will bite, but you got to think about the frequency at which people bite. So let's say people will buy at this higher price, but you only, like, make one sale per month, and it's not enough sales to keep your operating costs going. So you have to think about, like, the cash flow situation as well. So we need a nice balance between that. Now, there is a hypothesis, or I forgot who it is, the guy who talks about multiplying dimes all the time on YouTube when he's selling stuff. Multiplying dimes. Multiply dimes. Yeah, I'm gonna have to find that guy. Anyway, sorry, there's a hypothesis that you want to start at your bottom price, where you're not going to make any profit, you're going to break even, and then to get your listing kind of like up on Amazon, and then after you start to get people buying, then you kind of increase your price, right? That's a hypothesis of how to do things. And I think that's a good strategy, right? The idea is, like, make less money so you can make a whole bunch more later. So I might want to think about that as well. But I think the first priority is just kind of getting something out there, right? So anyways, we got these calculations and all that good stuff. Let's go look at the file here. So let's make a three-dimensional version of this. But before we make a three-dimensional version, let's kind of like shove things into different folders. So right now, I don't really have that much code. This isn't really much code, and like I have all these different namespaces, like components, moving, and transforming. And this is a namespace for fixtures. Right, we got all these different namespaces, but there's really not that much code. It's not enough to really justify that many namespaces. So what we're going to do is we're going to take all this code, right, that we've written so far for creating the model, and we're going to cut it and put it into a new file. So we'll cut this and put it over here. And then are we calling any functions to, like, okay, so here's where we're actually calling this stuff. Let's put this over here and save that. And we're breaking things right now, but let's save this as, underscore dot 2D, right? So this is going to be the 2D stuff. And I'm just going to say not enough things in this file to justify the typical namespaces I usually namespace files I usually use. So just put everything in a I can find it for you. Yeah, actually, here, let me find it. So strangely, maybe I'm just imagining things. This is gonna sound weird, but I swear to God, that guy who I'm talking about, he looks like somebody who used to, like, in the early 2000s teach, like, pickup art on YouTube, and now he's doing, like, selling on Amazon. Or maybe it's somebody totally different, but it looks like the same guy. But maybe I just can't recognize faces. Like, that could also be a thing. But let's go... Actually, let's just go selling on... He's probably popular that if I just go selling on Amazon, I'll be able to find his face in here. So not this guy. Let's find him. Selling on Amazon, Dime Guy. Let's call him Dime Guy. This looks like the right guy. God, that's a long video. Let's just go... I was, like, binging on a whole bunch of his videos, like, a few years ago. But I keep on going between, like, trying to figure out products to sell on Amazon and then going between, like, a coding engine. And when I don't have much money, I kind of, like, go towards code. And then when I have a little bit of money to start spending on, physical product and inventory, then I start to focus on that. So this guy on the right, is who I'm talking about. Yeah, just one dime. Yeah, so just one dime is who I'm talking about. So, yeah, his name's Seth. But I could be confusing his face with somebody else, so maybe I shouldn't. But I swear he started out, like, doing, like, dating coaching before he did this, but maybe I'm just confusing him with somebody else, but I swear his face looks, like, really, really, familiar. But maybe I'm just making things up. I don't know. It's like, if you've ever been to a different state, you might notice that, like, in every single state, I swear to God, like, there's a doppelganger. Like, so, like, so I went to college in Washington, and I swear to God, I found, like, 3 doppelgangers of people I knew in high school, in college. Okay, so let's go include that. So includes in this language are kind of different, right? So I always forget how to do it. But the include has no hashtag, unlike C code. And then we just do the file without quotes, so that's also another weird thing. It's like, okay, there's no quotes on it, and it's the actual path to the file name here as well. So it looks like this looks like a linker configuration style include, but it's not. And that's just confusing as hell, and there's no hashtag there. That's just the way it works. Okay, there. So we got this file back in there. And now we're going to comment this out. And we're going to make a file called, we're going to make an extrusion file. So, I don't know what I used to, I don't know if I had a shortcut for this thing. So, what we're going to do is say, okay, well, it's been a year since we did any of this code, so let's just try to search for things and make things up that aren't going to work. But then we'll be closer to being able to find these things the next time we look for them. So, new extrusion file. Okay, new ext file. New ext. New scad ext. New scad extrusion file. New scad ext file. New ext code. More ext code. Ext code. Scad ext code. Oh, you know what I think I might have called it? I might have called it underscore ext underscore ext underscore underscore dot ext. How about that? How about dot underscore dot ext? I don't know. So I have all these things. I don't remember. So at this point, we should just make another shortcut for it, but let's go steal it from somewhere else. So let's go look through our models, and I think we have like a snippet folder or something like that. So let's kind of look in here and see what we have. We have an art folder, batch, executable, framework, which we decided was a bad idea. We decided making a framework for this was a bad idea because then you forget how the framework works, and now you just have, now instead of how to do this, you have to be like how to do it in a framework. So it just doesn't help. I do find that... How about SCAD shortcuts? Let's see if we have a SCAD shortcuts folder or something. SCAD shortcuts. Okay, so we have a SCAD shortcuts folder. Let's go look in there and see if maybe we have a very specific file in here already. Moved. Okay, let's go look at this. Moved. Okay, so we don't even want that anyways. Oh, here's a folder called ext. I don't know what's called ext, so let's go look at this and see what this is. Nope. Okay, so what we're going to do is we're just going to make another snippet for this and say, oh, that sucks, but let's just steal it from something else and then clean it up. So, let's go look at, so this is one of the newer models, and let's just go look at how we did, like, the ext thing in here, right? So we got an ext. Let's just go take this, copy it, and we'll clean it up into, like, a shortcut. So, color by odd or even. That's nice, but we don't really want that. Top. And layer text. I think we wanted to do something different besides that. Let's go look at the index of... So we created an index for the date of when different projects were made. And we want to look at the newer projects. So there was this touch a spline block. Let's go look at the ext file for that. And see how we did that. So much cleaner. But it looks like... Okay, we could get something like that going. So EI stands for exterior top or interior. And then TB top bottom is deprecated. So before we used a variable called TB, and we want to use EI, which is the shorthand version for extend. So we're just going to steal this. And this is too much code. We just want like we don't want an example that gives us the idea of what we're gonna do. So rather than make a framework, what we're gonna do is we're just gonna create like little snippets that are ready to be kind of filled out, if that makes sense. So we're gonna say like namespace kanji. I have like a namespace kanji, or I thought I did. Yeah, namespace. So namespace -k. So a little namespace kanji. I just use this kanji to mean namespace. And the code isn't going to compile if we have kanji in it. So I'm going to use these kanji to be like little placeholders, right? So COM is for component, and then EXT is for extrusion, right? So EXT extrusion. And then CLM is for component namespace. So the idea here is that, right, we're going to create three-dimensional components by just taking the components and wrapping them in an extrusion, right? So an extrusion that is for this specific library. So anywhere we see this TSB, we should be putting the namespace. Okay, and so now in here, the exact math for this may change depending on how many parts we need, I believe. Actually, no, that's not true. This is all we need. Okay, cool. So I need to take a quick break, though. And then I'll get back to fixing this up. So, actually, I don't know if this is going to be a quick break. Give me like 16 minutes. I'll be back. Okay, so that sucks, but oh well. Oh well, I should stop screwing that up, but I keep on screwing it up even though I have the preview up on my other monitor. Right, so the square and the rectangle, these are just wrapper functions, and the wrapper function is going to call, we're not actually going to use these arguments, they're just going to be ignored arguments, and we want to find, so this panel is our rectangle, so the rectangular thing is the panel, and then the square thing is panel, and then non-overlapping slat, panel holes. I honestly couldn't tell you. Did we just put everything in here? Hold on. That's sure what it looks like. I think non-overlapping slat is actually the function for the... That's like a horrible name for this, but I think that's what's going on here. And let's include the files, right? So we have the 2D file, and then we also want to include the ext file. So include the extrusion file. Save that. And let's comment this back in, make sure that we can still get this working. Yeah, so this non-overlapping slats thing here. Is this the... Okay, non-overlapping slats is that. And the panel is the square thing. Is that what's going on? Yes, that is the case. So I got that completely non-overlapping slat. Oh, it's called the non-overlapping slat because the slats don't, they don't interlock with each other. So the slats for all four sides don't interlock with each other, which is, which might not make any sense unless you've seen some of my other models, which you haven't. So we could say, called a non-overlapping slats, because these slats that make the sides of the crate do not overlap with each other in the way they did in previous box designs. Okay, so made a note of that. We can make a note of the video as well. So it's a video. Oh, well, we still said this was 148, so... Okay, 147, 140. Okay, I'm good here. Just making sure the video number is right. So at vid IID, 1 hour, 2 minutes, and 42 seconds, because we want to be cool. So we can keep a note of exactly what video I was making when I did this, right? And okay. So now the next question is, did we do that correctly? If we did that correctly, then let's just comment this stuff out now. Let's comment this stuff out, and let's call the extrusion version. So we have extrusion square, and we don't actually use this EI variable. But let's But let's just give that a run and see if that looks correct, right? Okay, cool. So we got this, and the difference is there's thickness, right? So there is now thickness in this design, right? It's all we did was extrude the cutout, right? Plain and simple. But now we have like an actual shape that we want to work with, right? So we kind of have like this dovetail box side is kind of what this basically is. And we also want to get the size, right? DTB, EXT, rect, right? So we have a rectangle. And the rectangle It's probably a, you know, rendering right in there as well, so we can't actually see it. So the next thing I think might be good is having some type of color coding for this, right? So we have this. What if we did? Well, let's not worry about that for right now. Let's just put the color out here, right? So we're gonna create a color module as well and create a shortcut for that. I'm gonna color this red, and we're gonna color this like blue. And we don't have the function names for this right now, but I created like a shorthand color module so that I could just like use like certain letters to mean certain colors, and I made a extensive palette of primary, tertiary, and quaternary colors that are exact. So exact primary is red, green, and blue. Exact tertiaries, which are cyan, yellow, and magenta. And then also exact primary, secondary, tertiary. Did I say tertiary? Sorry. Primary and secondary, right? RGB and CMY. And then also exact tertiaries and quaternary colors. So let's, this function shouldn't exist yet. So let's go into the, one of the things that we wrote last, right? Tetris spline block or something. And let's look at the color module for that. So the color module file, was it this complicated? Oh, so I stole stuff from the framework 4 folder. That's how I got the stuff. Okay, a string or a tuple, and then color def input is defined. Gaia. So this is a color module where it takes invalid input, right? If it has an invalid input, it's going to color it as snow. And this is a color function that you could think of as a private function that it's going to assume that the input is defined, right? So def for defined, okay. And then just a whole bunch of crazy stuff just to define the exact color codes for what I'm doing here. And this looks like, you know, making sure that the tuple is in certain ranges, like 0 to 1 ranges. I don't know why I have 2 functions that look almost identical to each other. Oh, I see. This is a function. Oh, I see. One is asking if it's a tuple, the other one is asking if that tuple is in range. It looks like I never used this function for anything. Like, it's written, and it looks like it's proper, and at one point I think maybe I wanted to do a range check on the tuples, and then for whatever reason I did not. So we have some kind of technical debt of, like, something that I thought I was going to implement that I never used. You know what? Oh, well. We're not going to be perfect about this. Let's just get stuff working, right? So let's just copy that and paste it into here. And maybe we want to make note of where that's actually stolen from, right? So, So we could have like a little info kind of section here where we keep just an idea of like what's going on here. And then we can also make sure that, you know, this is all completely symmetrical because we're OCD like that. And we'll just wrap this up, right? So after we got this, we'll just wrap it up and say, shortcut is going to be scadtem, right? Scad template color, right? Because that's how we named the other shortcut file, right? Similar naming convention. And then we're going to take that, and we're going to go down to the bottom and kind of like make the same kind of section divider, right? So down at the very bottom of all of this, we're going to section divide this and just say that the shortcut is called scadtem color. And then we're going to steal this and save it somewhere. So we're going to go back here. We made a snips folder, right? A snip folder. And the reason I'm going to make an actual snips folder in the repo rather than in my personal shortcuts is because sometimes I work on this stuff at the machine shop and I don't have access to my shortcut script there. So sometimes I'm going to actually have to take these files and cut and paste them rather than access them through my shortcut. So we're going to call this color because it's the color module. And now that we have this, we can full file path to clipboard, and we can add this to our so new color file, scadtem color, right? And we want to paste this file, and we want to scadtem color, scadtem col, scadtem col, scad template color, and then scad col, right? Scad col. So it looks like I already had a thing for this called Atomic. So, oh well. Okay, so new scad color file. New scad color. Pick yeah, and sometimes as we're kind of like doing things, we run into, you know, so it seemed like we had a snippet for the underscore color file, but we didn't have words for the underscore ext file for whatever reason. I don't know why. But now we have more ways to find the things we're looking for, even though things are kind of in this cut-paste kind of like... When you cut-paste things all over the place, you end up with a lot of redundancies, which can kind of be bad, because then you don't know what's the canonical version of something, right? So when we're talking about code reuse, that can be the reason why you might want to have a canonical library. But for me, for little things like this, just cut, paste is fine. And so we have this thing, which we copied. So this is our little thing here. And this color module has no namespace in it, like no namespace related to the project, right? So we just got to cut it and paste it, and we don't have to actually change anything, which is nice. So let's just take all this, copy it, and we're going to paste it one more time into the current project, right? So the current project. Alright, so now we have this color module. And let's close this, let's close that. And in our main file, we need to include the color module. So color can actually come before the extrusion stuff. So include color. And now, hey, look, we can see that blue thing, right? Because I said that they're probably like on the same layer, and that's why we weren't seeing the part. Okay, now that we have this, it's time to like rotate stuff around, right? So this blue thing needs to be rotated. So let's rotate it by 90 degrees. So R9 on the x-axis, right? So if we have the correct rotational shortcuts, yep, there we go. And then we also want to move it up or down. So we want to translate it on the x, and we want to translate it on the x by a certain amount of lugs, which would be in terms of, so we want to move it by lx, right? Lug x. And I don't know how much we're moving it by, 0 plus or 0 minus 0. We don't know how much yet. So, but if we look in here, we have some constants, and we know that somewhere in here we have how big the box is. So we have the box span. So we want to move by this divided by 2, right? We want to move halfway up. So minus this divided by 2, right? And wrong axis, we want to go on the y. Okay, so now we're down here, and we have some problems. So one of the problems is we need to kind of like go we're like skewering the edge, right? So we want to go backwards. So what we do here is we're going to change our formatting a little bit, because I do this quite often. So I want to mark this as do skewer, or do it. And then ly 0 plus, and then lug divided by 2, or half lug. We're going to move by half of a lug, and that's going to be our unskewer. Undo. So we skewer the edge, and then we undo the skewer, is kind of what we're doing. I don't know how I usually label that, but that's fine for now. We also have to like move things up. Actually, this is perfectly centered, right? So the blue part needs to be is where I want it. It's the red part that needs to change. And also, yeah, we're good there. We're good there. So what we're going to do now is we're going to we just need to rotate, right? We need to rotate, and the problem with just rotating this a whole bunch of times is that we want to color it differently so we can see this. The rendering of this doesn't have like awesome shading, so we want to color each side a different color so that we can see what's going on a little bit better. So what we're going to do here is we're going to remove the color from here, because we're going to color it at a later date. Right, we're going to remove the coloring. The default color is this yellow. And we're going to call this something. We're going to call this like, we're going to call this DTB ASM, right? Because it's ASM because it's an assembly. It's part of an assembly file. And assembly, I don't mean like, you know, source code assembly. I mean like a literal assembly of different pieces, right? So, we're going to call it ASM. And we're going to call it, box, it's box side on in position. Okay, so it's called box spot, and then what we're going to do is we're going to this needs to be named, this needs to be a module. It needs to be turned into a module. And then we're going to call it, and we're going to color it different colors. So this is going to be like color red or color green. I don't know. I don't know what color. It doesn't really matter, just as long as it's different than the main kind of thing here. And okay, so now it's right there. And now we're going to rotate 0 degrees on the Z axis here, which does nothing, right? 0 degrees. Well, then we're going to duplicate this a whole bunch of times. We're going to duplicate it 4 times and rotate, you know, 90, 180, and 270, right? So 980, 987, or we could do 789 if we want to. But these are all the positions that we can rotate in, right? And now let's just say, you know, I don't know, let's do A, B, C, and D. Those should all be colors, right? So they're all different kind of colors, kind of very close to each other. Those are a little bit too close for comfort, these two edges right here. Yeah, A and B. C and D are really... Hold on, let's do capitals for a second. Oh, you know what it is? My colors don't go by letter, right? The letters don't... The letters are not organized in, like, the letters are not organized by their hue, right? So that's why I'm getting kind of these two colors kind of match, but these don't, because I just kind of threw out some stuff and... Okay, so, because I know, like, L is like a lime kind of a color, like an electric lime. And so let's, how about we just spell something out? How about we say lame? There we go. Except those two colors are too similar, right? They're different colors, right? Because their quaternary color palette means that sometimes you have colors that look very similar. Box with an E. How about that? Box. Okay, let's not be too picky here. So we got the blue, and then over here, this needs to be something else, like a purple. Sure, there we go. So you can see that we have this kind of radial symmetry here, so that you see how the yellow and the purple is kind of like interlaced here, right? And so that's going to make it so that we can put together these box sizes. We can assemble this box and make it perfectly square, but we only need 2 parts, right? That's why we have this kind of interlacing here. Also, that means that that's also going to bode very well for the stability of the corners. So now that we have this, we just want to move up this, right? So we want to say, like, you know, we want to go, like, lug x, and we want to move it up by however much, however the depth, half of the depth of the box, right? So, so the box depth, also known as the slat height, we want to move it up by the box depth, and then we want to move it up even further. So 0 plus the box depth divided by 2, right? Because right now it's in the center. Like, all my things are origined in the center, so we have to remember that. And also, this is the z-axis. So there, we've moved it up, but now we notice that right now it's kind of tangenting this line, and we have to get it off this line. So we got to move it up by half. So I'm going to say this is do it skewer. Right, we're skewering this line right here, and we want to now do LZ 0 plus 1/2, like a half of a lug. And this is, you know, do it undo. Sorry, undo skewer. Or we're backing off that edge, right? So now we're no longer intersecting the edge, and you can see how this kind of like all fits together very nicely. So here's what I'm talking about: corner stability. You see the orange and the purple? How, because they're interlocked like this, pushing down on here isn't going to make this bend out of control, right? Because we have this support right here, but then over here on the you see this red section? It means this orange section has no support, but then it's interlocked with the purple section, so it has support, right? So you want to think about we want to reduce the amount of surface area in the plan, right? Because the more surface area is the more cutting, and we want to reduce that surface area, but we also want to make sure that the design has a structural integrity. So I think this design has some pretty good structural integrity, and we're going to use this as a crate, right? We're gonna put the product inside this crate, and we're gonna ship it. So let's take let's make this like a dark red. So make it a dark red, and then let's just mirror this mirror on the z-axis. If we mirror it on the z-axis, we're gonna see it both. We have the top now, right? So there we go. We have a nice little top, and I think it'd be nicer. I like the, as we're looking at this, I'm thinking the purple and this yellowish look nice. So this is the purple, and this is probably like electric lime. That doesn't even look like lime. It's a very bright lime color. It's almost yellow, but there's a little bit of green in it. So I called it electric lime. I believe that's the case. So if we call this PEPE, we're going to have that purple and that lime color. So there we go. So now it just looks a little bit better presentation-wise. But you can see what we're doing here, right? How we're kind of like making this box design. And, right, this box isn't going to hold on its own, right? So we've got to duct tape it together. Eventually, we can work on the tolerances so that after it's cut, that these wedges kind of, like, we can, like, mallet them together, right? We can get a mallet, and we can go boom, 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 and, like, really bang in the sides to, like, make this box nice and sturdy. But for right now, this is a good design. Now, the other thing is we might want to work on a logo, like a logo version of these boxes, right? So, the first thing we might want to do is, before we, like, go anywhere, let's put it in, like, a perspective view, right? And let's just take this, and let's try to get a screenshot where we can fully understand what's going on with this box. Like, what kind of screenshot could I use to kind of fully recreate this box? So I think that would work. I think that's enough of a screenshot where, like, if I was to look at that, I would be able to fully recreate what's going on. So what we're going to do is we're going to snip this. Oh, actually, before we snip this, let's take this whole thing, right, and put it into a module, right? So module, DTB, ASM, and we'll just call it, there really is nothing else, right? We could just call it main, right? It's the main assembly. There's no other assembly that I'm interested in. So let's just call it main, and then we'll run it again, right? So we'll run it over here. And now that we have a name for it, the reason I wanted to wrap all that code into a function is because I have a habit of take what I've made, right? And then we can save this. And when we save it as a PNG file, right? So when we save this as a PNG file, we're going to save it as the exact name of the function used to make it. So in duct tape box, we're just going to save it right here. We're going to call it, you know, DTB ASM main, right? So that way, when we're trying to look for code, we can look at the file. We can look at the images and know exactly what code we need to look for if we want to, if that's the thing we're interested in. So DTB ASM main, and Now, I would like to put a logo on this, I think. I think that if we're going to take all this time to make this quality box, we really need the parts to have some type of logo. So let's get on that, right? Let's get on making some type of logo for these boxes. So before we do this, let's move this assembly code, as in assembly, not like assembly code, but like a model assemble code. And let's save it as asm.this, right? This is the assembly namespace. And we'll say full file path to clipboard, because right now this isn't going to work anymore, right? Because we cut and pasted this into another folder. So why is this still working? Oh, because we didn't save this yet. So if we save this, now it's broken, right? So we have to take the, we got to go include, and include the, this 2D should probably come after ext, I believe. Because ext is 2D stuff. So we're going to include ASM here. ASM takes the extrusions. 3D extrusions, right? So we take the 2D cross sections, we create extrusions with this file, and this file has like three-dimensional assemblies. Okay, so now that we have this, we want to just throw a little logo on that. So we have like a DEKTEN font that we're going to use. So let's see if we can do that. So include DEKTEN stencil font. Include our use DEKTEN stencil font. Stencil letters sl.scad, is that what it is? I think that's what it is. And also it's a use function, not an include, and I might want to remember that. So let's go. I don't know if this is the correct amount backwards we need to go to like get to what we're looking for, but it might be. So it's not. So we're inside a model. We got to go back to. We're in duct tape box. So we got to go back to M. That's 1. Then we got to go 2. So we got to go 2 back. So we have 3 back right here. We only need to go 2 backwards. So okay. So there we go. And let's comment this out and let's get some text going here, right? So let's see if that's the correct thing anyway. So in our art folder, we have, oh, we already have a thing called DEKTEN logo, right? So we can just say, DEKTEN logo 02. Actually, let's open this up with, let's go. So we have a UPAT art folder, right? And we have this thing called DEKTEN logo 02. And we have a screenshot. So let's look at that screenshot and see if perhaps... Okay, that's a nice little screenshot, right? So here's the font, right? And I don't know what this is about. But I'm going to guess that this was, you know, maybe refactored. DEKTEN logo uses the stencil letters, right? So it's the idea is that instead of working with those stencil letters, we can just, you know, include this. And it has like a function that already uses the stencil letters, right? So use stencil letters, yeah, sl.scad. Okay, so we got like a main. Okay, so we already named a main function, so that's cool. Let's do a shortcut for that as well. So, and we'll call this one include DEKTEN logo. Or if we say use DEKTEN logo, same thing. I don't know how these angled brackets are going to like my shortcuts, but we'll see. We'll see in due time. So no crashing, so that's good. And then all we want to do is like run DL2 DEKTEN logo 2 main and see if that kind of shows up. And I already see a problem, which is we don't have like, what size is that rendering at, right? Like, oh, it has a 1-inch variable. And so yeah, that can create problems depending on if we use different scale factors for things, right? We might have to make something a little bit more robust. Make a DEKTEN logo 3, where we kind of specify the scale for things. But for now, that's fine. I mean, we just want to shove a logo on it so that it's branded, right? So now that we have that, we want to go into... We're going to go steal this. We want to go into the code for this 2D stuff. And... we want, like, a logo pass, right? So... we could try to hack this a little bit and just say, you know... if, x equals EI, then we write the logo. Alright, so we put it on here, maybe? That's still gonna need more work. But then what we can do is we can take this thing here, right? And let's give that a run, right? Let's give that function a run. So this component here. And there it is, but now if we say, you know, ext for exterior, no dice, it's probably not being passed down. So let's go look at component sqr. Oh, I see. Oh, yeah, because it needs to be... Let's just do a difference. Alright, so this is kind of hacky, but right, a difference between this. Actually, no, let's just make this kind of straightforward. I keep on changing my mind. So we're going to just say here, we're going to take the main logo. We're going to subtract the main logo from this module, right? And we're going to call this difference. Alright, so it's not the best way to do things, but it's dead simple. So... and then else, we just draw the model as is with no logo, right? So if this, else we just, you know, draw this, right? Nothing there, right? Okay, so now we have this nice little thing here, where we have a nice little logo in there. And you know what? That scale's fine. I think that scale's fine. That works for me. Now, we do have to remember that the bigger we draw the logo, the more effort it is, right? So, we may want to just make our own logo here, because I think that, do we want to make it big like this, or do we want to make it smaller, right? Like, I don't know. Like, it's cool being all big like this, but it's the, hold on. But if we make it all big like this, it's further for the laser to travel, right? It's further travel time. So I think that not only is it further travel time, but making it smaller gives it more of a professional, more elegant look to it. Like it's hard to make sense of what I'm saying here, but the proportions really matter in artwork. And if you use very big, blocky proportions for things without any very fine details, things look childish, right? So this font here may look more childish than it would at a smaller size. So what I think is we might just want to use the stencil font, right? And so linear text, and then we're supplying a 1 inch variable, right? So this is what 1 inch equals. And so let's just take this, and in our file here, let's just call this, you know, DTB logo SQR, the logo for the square thing, right? And it'll be this stuff, and we'll call this module, right? And then we're going to take this, we're going to close this, we don't need that, and we're going to close this. So here where we're calling this DEKTEN logo to main, we're going to call this instead. And it's the same thing, right? Because it was just a cut and paste job. But then we want to just say, to change the scale, we're just going to change what it thinks 1 inch is, right? So we're not going to, right, there's other ways we could do this, but I think it's going to be easier if we just say, you know what, 1 inch divided by 2, right? And then bam, it's smaller because it thinks 1 inch. The variable, the native units for whatever 1 inch means has been scaled down, right? So scaling it down like that makes it look a little bit better, I think. So now, right, it looks a little bit more... It's going to take less time. Now, we could do by 4, right? We could do 4 times, right? And now it's, like, right in there, pretty small. How small is that, right? This is, like, 12 inches, so that's not actually too small. I think that would work. But I think if we have a screenshot of this product and we have this, like, little stamp here, is that what we want? Yeah, let's err on the side of this, because let's err on the side of smaller rather than larger, because people can still read this logo, right? It's still going to be burned in there. But it's also going to be something that that's going to take less time to put on the box, right? If we make a gigantic logo, we don't want a huge amount of our cutting time to just be stamping this logo on, right? We just want the logo so that we can kind of like put it there and be like, yay, we have a logo, right? So now that we have this thing here, let's copy this, and I'm thinking it's going to be the same thing for the, so we have the square and we have the rectangle, right? So let's go comment this out, And let's call the rectangle version, the rectangle part. And this also needs to, we also need to include how we're going to render the logo, right? So right now we have this kind of like very bulky kind of thing going on. I think that's fine if that's how we want to roll with it. And non-overlapping slat, right? So we're just going to take this and say, we'll put this right here. Even though this isn't where we originally wrote the code, but, you know, we can keep the history of what was going on there. And then over here, we want to take this, and it needs to be called in the same place, right? So this is kind of ugly where it's being called in two places like that. But now, that's kind of nice because now this part here has the same logo of the exact same size, right? And so I think that's a nice little feature to where we cut all these parts, and we can burn the logo into them, right? Okay. So now that we have these, we need to create a cutting sheet. So we need to, well, actually, we don't really need a cutting sheet in the sense of what you would usually call a cutting sheet. But we need to get this ready for the laser cutter. So let's get this ready for the laser cutter, right? So let's take... Right, if we change this X to interior, right, that logo, yeah, okay, cool, X. Okay, so let's comment this stuff out. And let's create a file called, file new. And let's say DTB cut. And we're going to call it SQR. And I'm going to call it EXT. So we're just going to take, basically, it's really simple. We're just keep creating wrapper functions so that we have file names to grab onto. But really, that's all we're doing. So we have the exterior and we have the interior, right? So EXT and interior. And then we want to do the same thing for the rectangle version, right? So the rectangle, instead of calling it square, it's rec and rec. And then we want to save this as underscore dot cut. And now that we have these, we're going to create their own file. This might not be the best organization here. Hold on. Sure, why not? So, we're going to include, and we're going to go back to dtb.scad, right? And then we're going to call this. And then we're going to name this file that, right? So we're going to go into the cut folder. We're going to create a cut folder called cut. And we're going to name this, let's call this SE. SC.scad, sure. We'll call it SC.scad. And so SC is for SE. Square, exterior. Right? And let's close this. We don't need this one open. let's open up this and make sure that looks correct, right? So it's saying, I don't know what this is. That's what it's saying, huh? Because we actually have to include that, right? So we got the assemblies, we need to include cuts. So include cuts. DTB duct tape box cut SQR EXT. I thought that's what we had. Oh, because we're being stupid here. Module, right? We gotta these are modules, so we have to declare them as modules. Otherwise, we're just calling functions. Okay, so now we have this right here, and we do want to screenshot this as well, right? So we want to say we want to snip this and save it, right? So we're going to call it se.png. Okay, so that means that somewhere there's a se function, right? So let's just say module se. I know it's a little bit convoluted, but the idea is that we want some type of function with that name, right? That if we have a file like this, that there is a function of the same name according to the PNG files are named based off of the function that was used to create the screenshot. So we want a way to easily link the image to the code, right? So when we see a cool image and we're like, oh, that's a cool rendering, what code do I have to execute to get that rendering? We want a way that we can kind of figure that out. And so this is kind of superficial to wrap it in this, but that way we know we can easily find it. So anyways, now that we have this, we want to file, and we're going to save this as, actually, my bad, file export, and we're going to export it as a SVG, and it's just going to be se.svg. Yeah. Okay. And we're going to copy this because we need to do this for a few other files, right? So file new. And we want the interior, right? So si interior. And so everywhere we see the e's, we just replace it with an I, si, and then this is interior. Okay. In our cut folder, we're going to call this, square interior.scad. We're going to close this one because we're done with that one. And we're going to close this. What do we got open here? This is different. Yeah, so this right here, we're going to open up, we're going to go in the cut folder, and we're going to open up this SI thing here. And if we look at this, right, it is not a square, that's for sure. So let's go look at that, see what we screwed up here. Well, first of all, we just majorly screwed up with our naming somewhere. We did something completely stupid. Let's go look at the cut folder. Square, rectangle. Okay, so this is proper. And what does the square exterior look like? Oh, hold on. Okay, how do we screw that up? So why is this square exterior looking like this? One's a square, one's a rectangle, and we gotta fix that. So the interior is not rendering correctly. So this square in, we go look at square in for a second. So square in, oh, we didn't refactor everything correctly. So if we look for a rectangle and we look for square, we notice that this interlacing is improper. Okay, so now this interior version is correct, right? So we're gonna file and export that as a SVG for the laser cutter. And we're gonna call it si.svg. Right? SI for square interior, SE for square exterior. Okay. So now that we have this, we want to screenshot it as well. Right? We just want to, it doesn't need to be a perfect screenshot. It's just enough for us to, like, after we haven't looked at this code for like months or years, we can see the screenshots and know where to find stuff. So we're going to file, save as, and we're going to save it as, you know, si.png. And also, all of the images are going to be at the root of this models folder, right? We're not going to nest it because one of the first things I want to do when I'm looking at models that I've already designed is I just want to, like, open up the folder for a specific model and just look at all the screenshots to get my bearings and get an idea of what the heck it was, right? Instead of looking at the code and try to guess. Or try to run the file and maybe the file is broken, or it just makes the workflow a lot easier. So now we just need to keep on doing this, right? So square interior, square exterior. Let's go create the next files, I guess, yeah? So we could be able to, we could do this. Let's kind of batch it in one go here. It's all right. Oops, Control Z. So we have the interior and exterior files, right? We're gonna just change these to wherever we see this. We're gonna change it with rec, right? Same thing with here. And you see this, and this, and this, right? All of that is going to be changed with rec. So, rectangle. This is going to be R for, yeah, and this is going to be R. And this right here is going to be a rec. This shorthand name is kind of getting a little bit dangerous because RI, I have a function called IR for inch rectangle, and so by making these little two-letter things, they could potentially conflict with some of my functions. So I need to be careful with this in the future, but it'll be fine as far as this goes. Yeah, I need to be careful of that though. So this is RI, so let's just say this as, you know, RI.scad. And then over here, same thing, right? So where we see S's, we need R's, and this is going to be rectangle exterior, and this is going to be R, this is going to be R, and this is going to be rec for rectangle. And then this is going to be RE for exterior. And then we might want to just swap back and forth between these and make sure that they just look pretty much identical, except one has E's and the other one has I's, right? So then we're going to open this containing folder in Explorer. We're just going to double-click that, give it a look, make sure it looks correct, and then take some screenshots. So, okay, so that looks correct. So let's just take a screenshot of that and name it accordingly, and then we'll export it. So, File, and we're going to save as ri.scad, and we're going to save it in the cut folder, the cuts folder, ri.scad, or sorry, not ri.scad, geez, geez, I'm just totally wrong here. We're taking a screenshot, so ri.png in the root folder here. Okay. Then we're going to export as a SVG. And we're going to call this one ri.svg. Okay, sorry. I got things kind of backwards there. Okay, now we can close the interior and we can look at the R exterior. So this thing here. And let's zoom out. Let's render this. Render the line path. And then let's just screenshot this as well. So just take a snippet of this. And we just want to screenshot this right here. And file, save as. And we're going to save it in the root. So it's going to be RE, because it's the exterior, because it has the logo on it. Okay. So now we got that. And then we're going to export this. So file, export, SVG. And it's the rectangle exterior.svg. I like capital extension names, so I'm going to save it like that. And now we have the individual parts that we actually need to be cut. The next thing we could do is actually create a file that has this part with the rectangle on it, right? So I know the rectangle is less than 12 by 12, but I don't know if it's so much smaller than 12 by 12 that we can afford to I don't know if we can afford to try to cut any other parts along with this. I don't know if it's that small that it can fit on a... If we try to cut this out of a 12 by 12, I don't think there's going to be much left. But I'm not sure. So let's go to the main kind of file here for a second. And there's nothing at the top level, so we need to just go in here and edit it. So let's close this, let's close this, let's close this. And let's just doodle here a little bit. So we just want to say, like, okay, so we have this rectangle exterior thing, right? And that's like, oh, because that's not included. So we got to go dtb ext cut, and then rectangle ext, right? Did I get that right? Yep. Okay, so we got this thing, and we actually wanted to cut the square. And we're wondering, hey, how much room do we have? How much extra room do we have? So let's just do an inch rectangle. So inch rectangle, and we're going to do, you know, we're going to do 12 by 12. And we're not going to put anything for this third parameter. And I just want to know... Oh, sorry, not inch rectangle, my bad. Inch bounds. Okay, so if we do the bounds, you can see that there isn't really much room to work with around here, right? So you see this bounding box around here? That's the 12 by 12 region. So if we're cutting this out of a 12 by 12, we don't really have much extra to go around here. And that looks a little bit suspicious to me, actually. It looks like... because these slabs should be like 10 inches by 10 inches slabs of product, and this looks a little bit bigger. So I'm seeing this box span is 11.5, and I think it's 11.5 because this is the outer bounds of that box. And we see that we're inset by kind of like 25 and 25 here. That makes the box 11 by 11 for whatever is going into it, right? But we know these are 10... These sheets of acrylic are supposed to be 10 by 10 sheets, right? So this is wrong, right? So let's... We have a configuration section, number of sheets to hold. Span of sheets. Sheet span in inches. So it holds 10 sheets, but the sheets themselves are 10 inches in size. So with this span variable, we have right here, we have this box span, and we see this kind of like 11.5. That should actually be... It's not 11.5. It is plus size of material being held plus 0.25 on each side to account for thickness of material. So now we have a material thickness in lugs right here, so we might want to change this around, but hold on, let's run this for a second. So you see this? Let's make this less fragile and not hard code this in here. And say... So with this formula... plus... Right, so this... thickness of walls of box. So this is the thickness of the walls of the box. So you see this the size of this did not change. We just changed how we wrote the formula. So we got rid of that hard-coded 0.5 to make this a little bit less frail of a formula. So now that we do this, so that was a good call. I just realized that I rendered my box to the wrong size. Now, I do realize that the proportions are a little bit different now, right? Because now you see how this kind of interior is a little bit different. So do we want to slide this around a bit? I guess we should try to slide things around. Now, I don't know exactly where we... I think we had like a translation function, right? So if we go into the 2D functions... There is a transform. We have a move function. Oh, we declared a variable called tanpegdist. So we could make this 9. We could turn this 9 to a 10. That looks worse. How about 8? So that looks kind of like more symmetrical, right? So let's make this a 7. So this is an 8. This one's a 7. I honestly don't know what the best size is. But here's the original 9 we had, right? So the original 9, which shifted things around because of how we edited things. For the most stability, we want kind of half and half, right? So we want roughly half extruded. We want half poking out and half poking in, right? So the most balance, so 1, 2, 3, 4, 5. So this is already kind of uneven already. Let's change that to a 7 again. I think that looks better. We could do a 7 or a 8.5. Right? We could do a 7.5. Right, we could probably figure out a number where everything is kind of completely symmetrical here. And maybe we want to do that, right? Maybe we want to maybe we want to move this stuff around until we find something where the dovetails are kind of like all kind of like completely symmetrical, right? Because maybe the more regular the structure is, usually the better from my experience with like happy little coincidences and whatnot. So what we could do is we could just take this thing here, right? And we could... Oh, actually, we don't even need this, right? We could take the rectangle version. So we could do... Oh, we already have this thing here, right? So let's steal this. The panel is not what I wanted, though. So my thought is that if we offset this, all the lines should kind of line up still. So let's say instead of minus 10, let's minus like 8 and 2. How about 4? Okay, there. So we can kind of see how it lines up. Maybe like 3.5. Get like really close, right? And now if we offset this, we just want to see that it still lines up. Like if we offset this over here, does that still look right? So if we say like LX 0 minus 5, I don't know yet. We're just gonna have to experiment with that number. 11, 16, 17, maybe 18. We're getting close. Oh yeah, so there we go. So we can see that. Well, hold on, that's not what I want to see that lines up. We already know this lines up with that. What we don't know, though, is we don't know if the two, hold on. We don't know if the divots are... So this divot here, this divot right here doesn't match this, right? So, so we need to make this a little bit smaller. Oh, hold on. What did I do? Let's do 3.6. Okay. So this divot right here does not fit perfectly into here, right? So everything's not completely uniform. And so we need to contract this a bit, right? So 7.5, let's say 7.0. That's the other way around. So we want to try like 8. And now with 8, we see that we get things kind of lined up really nicely, right? Where this goes into that, and this goes into that, and then we also want to make sure that this part right here matches up with that part, right? So let's move this over, right? Let's move this over like 10. And this might actually not match up. This might not actually line up. And you know what? If it doesn't, I'm not going to worry about it. I just wanted it as regular as possible. So it's not completely regular, right? So that isn't quite the same size. Okay, well, if it's not going to be completely regular, right, do we... And why is it not completely regular? Because the... because the spacing and the size of these both need to be affected, right? So we have this distance, and then we have this thickness width. And both of them need to be, the thickness of this needs to be 1, 2, 3, 4, 5. It needs to be 1/5 of, like, if we really want this to measure up like that, we can do that. But that means that this width needs to be, we need to take the span, right? So we need to take the span of the box. So this is the span of the box. And if we really want this to work, then this needs to be divided by 5. Okay? And then that also means that, I don't know about the spacing here, but I think the spacing there also would need editing. So this 8, if you make this a 7... Okay, so the spacing from the center... needs to be what? So first... So let's change this. So this distance here, if we change it to 0 for a second, right, it's just going to be, that peg is going to be, like, exactly in the middle. That would probably be the simplest design, honestly. Now I'm thinking of it, right? Because now we just have one of them. Alright, we just have one of these, and we have less cuts, but I don't know if that is the most secure way to make it, right? So if we want this to be more balanced out, we have to take the width of this, right? So the width of this, which is 1/5 of this, right? And if we move these both by that, I don't know what's going to happen. Let's just try that. Not what I thought. So that puts it all the way at the end, which is interesting in its own right. There's a lot of interesting things you can get from this, right? Let's just keep on editing it manually. 20. 10. Okay, got ya. So 4. Okay, so this width here is what's going to make them tangent each other, right? So this plus, if you do a +1, they're going to have a gap, right? Okay, so we have this width here, which makes them separated, and this is 2/5. 1, 2, 3, 4. This is 2/5. We need to take whatever is left over. We need to put one of those 5th gaps in the middle of this, right? So we want to take this gap right here, this 5th gap. So this gap of fifths, we're going to need to use in 2 locations. So let's just make a thing called gap of fifths. And then let's put this over here, right? This gap of fifths needs to be here. And then it also needs to be here, plus the gap of fifths. Right? Okay, so now that doesn't look correct, does it? Oh, you know, it's because this distance is being used on both sides, right? So we need to take the gap of fifths and we need to divide it by 2 because it's moving away from the center. Both objects are moving away from the center, right? So that's doubling it. So we have to divide that by 2. And now I'm fairly certain that that all lines up correctly now. So with that, we can, if we mess with the movement, right? So not everything is everything is probably in like really weird increments now. But if we try to move this over, right? So we got -9. Let's do minus like 8.5 or something. Right? And you can see this kind of lines up exactly with that, right? And now if we try to like minus, I don't know. Let's try to make this kind of line up in there. So let's say 0. Right? You can see that still lines up. So everything kind of lines up, right? So everything's very uniform. So we've made the structure much more uniform, and so I think I like that kind of refinement. Even though we're never going to connect the panels in that manner, because it wouldn't be very useful. But we have the ability to do that now. Okay, cool. I mean, I guess technically you could put this panel, you could take 2 of these square panels, put them next to each other, and you could, like, interlace them to make an even bigger panel if you really wanted to. But I don't see too much utility in that for my current use case. Okay, so we've edited the proportions for this all over the place, right? We have messed around with this, and yeah, we've messed around with it, and that's cool and all. Let's clean up after ourselves, but also let's see how much room we're taking up. So we're taking up this amount of room, and we're thinking that maybe, just maybe, we could get something in here, right? Maybe we could get another part in there. So we're thinking, you know, we could do like a LXY and go like 0 minus 1, 0 minus 1. I don't know how much we can move it by, but let's just shift it over a bit, right? Move it over by 3 lugs. Okay, so if we wanted it exactly on the corner, right? If we're gonna do this exact, and usually we probably could do that. I mean, that makes me a little bit nervous, but let's take that and then do LXY or LX. 0 plus, I don't know, 18, something, I don't know what the offset needs to be here. And we're going to make the rectangle, we're going to put the rectangle above that and see if we can make like a nice little cutting sheet where we have, oh, this also needs to be the y-axis, sorry. And we're still off, so let's say 23. Too far, 21 maybe. So, if we were really careful about it, we can get these 2 in here, right? We could shove it in like this, right? We could move this, instead of moving this over on the X, we don't move it over on the X at all, right? And now, these 2 parts, they are, we would have to change the, some of the settings for how we're doing this, but because they're kind of like automatically merging with each other, which kind of sucks. But yeah, we could potentially get so let's do LXY for LXY. This was the Y, and if we move this over, right, so 0 minus 3, I think was the thing we did. If we move that over, then we can get the other one in as well. And I think we had a little bit of space right here, so we could do 20.1. 20.4. We're going to do 24.4, might as well do 20.5. So if we do that, we can get... right, if we duplicate that and do kind of the same things, right, the same offsets, but we... if we rotate this 90 degrees on the Z, that might not be the correct direction. If we rotate that, let's try rotating that. I want to rotate more like a 270. Doesn't quite get me what I wanted. Let's backtrack here for a second. Let's comment this out for a second. Oh, we really want to mirror on the 45, right? We really want to mirror on the 45, which I think mirror X... We want it to end up over here, right? We want it mirrored on the 45. And to do that, we have to, like, mirror and rotate. Screw that. Let's just say, you know, R0. Let's just put a rotation here of 0. Let's duplicate this line and just swap the variables, right? So we're going to say offset 1 is going to be this thing. The signs actually might matter, though, so let's not include the signs. They might matter in the transformation. So offset 2 is, you know, a 3. And we're going to take offset 1 and 2 here. Like that. And then we could duplicate this. And we already screwed it up, huh? Because this was like a 0 minus, right? Or one of these was... No, this was a 0 minus. This was a 0 plus. Oh, because my offsets are wrong. This was our 3. And this was the 20.5. God, I can't refactor crap. Okay. So then what we're thinking is we can just, like, duplicate this line and swap the offsets. And then not only swap the offsets, but then we want to rotate this 90 degrees. And we're getting close, but we need this offset to be plus, it looks like, on the X. And on the Y, we need to invert this. We need to change the offset. There we go. So now we have a mirror on the 45, right? We got a mirror on the 45. And that's good and all, but now we want the cut for... We want the cut for the square area. Now the square area is kind of like taking up too much room. So everything's kind of merging together. So this is actually going to be kind of hard for us, where we're going to have to create So we're going to have to make a cutting file, a cutting function. And we're going to delete some of those other vectors we made because we're not going to use them as a cutting file. Because if we have this thing where we have one panel and we have two sides, but we need two panels, we need two rectangles or two squares on both the top and bottom, right? So if we cut this blueprint twice, we have all the parts we need for one box. And then we don't have to worry about where we're going to get the extra material for the sides of the box because it's all right there for us, right? It all just fits there nicely together, and it's awesome, right? And it looks like everything kind of conveniently fits perfectly together here, right? Yeah, everything kind of like is. All that math just works perfectly. But the edges, because their edges are tangenting, they're merging together here. But I'm pretty sure that those are... Like, if we comment this out really quick, and we look at this edge here, if we comment this out and save it, let's just make note of this intersection right here, this little corner here, right? It maps exactly to this. So the pieces are now completely complementary, so now we can... Because the design is completely complementary like this, we can fit, we can make the most of our material, right? So let's this does also mean that we need to make sure that we're cutting exactly, we're going to need slabs that are exactly 12 by 12. So, any type of loss from kerf on the table saw is going to screw us over. So, what we should do is we should make this blueprint and then, let me think about it. Right, so if we can get this blueprint to work correctly, then we're at exactly $3.75 per crate. And that's good. Huh. Yeah, the kerf worries me. The kerf calculations worry me a little bit. I think we shouldn't get too picky about it. I think that this will work for our needs. And I am a little bit worried about the kerf, but I also am like, hey, we can save material costs here if we cut it like this. So, we should probably do it this way. Okay, let's, refinement is a later problem, right? We got all these hypotheticals of, oh, we're gonna lose too much kerf from trying to cut up these slabs. So, right, so we're gonna cut this, right? We're gonna partition this 4 foot by 2 foot into slabs like this, and then we're gonna try to cut these plans here, right? So we're gonna lose some kerf here on this line, we're gonna lose some kerf on this line here, right? And so if we're trying to snap this exactly to this 12 by 12, we're going to be out of luck in some cases, right? Like, everything's not going to be completely perfect. However, I think it should still be good enough to create a crate that can protect the product, right? The thing we care most about is, can this crate protect the product? So let's not worry about that for now. Let's just worry about, can we make, because $375 for the product packaging is already pretty expensive, right? So let's not worry too much about that. Let's just create a function that's going to help us create the blueprints to cut this stuff. So let's call this, you know, module DTB cut, right? It's cut, and it is rectangle and rec and right, we're going to cut the rectangle and the square, and it's going to take a EI variable for exterior or interior. Right, exterior, interior. And that's going to help us figure out this stuff. So instead of cut, oh, hold on. And let's call this in. Because right now it doesn't reflect the interior, right? We have to change this. So this EI variable, instead of cut rec, we're going to remove this cut rec ext and just say cut rec. And no dice, huh? Let's go find the cut files and see what kind of things we have here. Actually, no, we can just call this DTB com rec, right? We don't actually need to call it that, right? We can just call it this. That's fine. We don't need to make more functions. Then the EI goes in here. And then same thing with here. So let's just refactor this a little bit. Oh, because this is com. Okay. And now this square, right? This square, we're going to call this com SQR for square, and the external internal goes there. And then also we need to know so actually, instead of that, we're going to give it a layer. Okay, so if SQR, if rec equals the RS variable, then we're going to do this stuff. And then if, or else, if SQR equals the RS variable, rectangle or square, unfortunately, we're going to have to do some things that are a little bit weird, just so that we can get it, we're going to have to composite these, right? Because they're automatically merging in OpenSCAD. We're going to have to composite them in paint.net, right? So that's just the reality of the situation. Let's say module DTB cut module DTB cut Um... This is how we want to do this. Let's call it V1IR for version 1. And then we're going to take this in and rec. And then we're going to take this and X, right? And take this ER. We're going to copy all this. And instead of R, we're going to say S for in and square, and for X square. Right? And then we can version 1 cutting sheet. So I'll just call this, you know, version 1 cutting sheets. And right now, if we take one of these, right, we have this, and then if we do exterior, right, we get the logo, and then if we do square instead of rectangle, right, we get a square, and then interior doesn't have the logo, right? So that's all good. Let's steal all this stuff here. Let's take it, and let's go move it into the cutting namespace. So we have a cutting namespace. Let's go put that in there, right? So, and technically these are version technically these are version 2, right? This is my second attempt at this stuff, right? This is actually V2. Version 1 cutting sheets. This is the first attempt. The first attempt, this is version 1 actually. And these don't have any cruft, or they're all perfectly centered, but we're wasting more material. Waste more material, but we don't. Worry about material loss on the table. So if we use these layouts. So at vid IID, it's 0148, and the time is 2 hours, 44 minutes, and 23 seconds. Let's just do a T for time, because we're running out of room. Okay. So now that we have that, this technically was for, right, this was for the, let's just throw this into here, right? This is really kind of where it belongs, right? Because these are just wrapper functions for this layout function, right? So let's not let's keep everything nice and coarse, trying not to get too granular with how we're grouping things together. This kind of annoys me, though, so let's try to condense that a little bit. And now let's create files for each one of these things, and let's go into the cutting folder, and let's just nuke all of this, right? So we're going to nuke... yeah, we're going to nuke all these because we don't want to actually cut these. So we're going to just go... These are outdated already, even though we never even went to the machine to cut. These images here, they're like... Sure, they're not the exact proportions, right? They're not the exact proportions, but it's close enough to get the idea of what the heck we're up to, right? So I'm not going to worry about trying to re-render and re-screenshot these. That's fine. But in the cut folder, we want to give it another shot, right? So new text document, and just say, you know, v2. Oh, actually, we removed the... Hold on. Can we undo, or did we totally lose the things we just deleted? Okay, well, we lost those things we just deleted. Some of them were kind of helpful, but oh well. Let's not worry about it. Let's not fret over it. So let's just move on, right? So file, new text document, and it's going to be v2ir.scad. Okay, and then close this. File, new text document, and then we have a v2er.scad, right, for exterior. And then we have a v2 interior square.scad. And then new text document. And then also we have a v2 exterior square.scad. Okay. Now with all these, let's just do one at a time, right? So let's open this up. And also open it with the notepad, right? And just go, hey, we need to include ... dtb.scad. And then we want to go v2ir and just run it, right? It's just a function that's gonna call what we already have, so we can see what's going on, right? That's all it is. It's pretty simple. One of my worries here is that we need to make sure that everything is centered, right? So when we export this, if we don't have any bounds, we might find ourselves in some serious trouble. So if we do v2ir, what about a square? Or not, sorry, exterior square. Because it kind of fits... Well, actually, the lower bound is okay. We might find ourselves in some trouble here. Well, let's just try to export these two. Ooh, calcs are off. That's bad. So let's take this for a second, copy this, and look at where we say calcs are off, and make sure we know what's going on here. Well, how much is it? Echo. I believe you can just do this as another parameter. Is it close enough to 46 where I don't have to worry? Or is it, like, really off? Okay, that's really off. Oh, because 46 is because, our original calculation was wrong. And we're 1 inch off, right? So... Originally we had Were we 1 inch off? Yeah, I thought we were 1 inch off, yeah? So 42 versus 46. Yeah, that would reflect the 1 inch off. So yeah, that just needs to be 42. That's fine. We'll keep this. Yeah, okay. So you need to file, export as SVG. Save that. And that's not how it. God damn it. Delete this. Okay, V2IR, right? V2IR? Is this an IR? That's not an IR, right? Okay. Okay, that is an IR. This is what we want to export. File, export, SVG. SVG with the exact same name as the file, which calls the same function as the file name, right? And we just want to do that for every single one of these, right? So V2IR was from here, and now we just want to keep on going through every single thing here, right? So V2ER, and we're gonna have to open that in Paint in Notepad as well, right? So open that in Notepad and say, hey, you know, include /gtb.scad, and then V2ER is the function I want to run. And then we want to just look at what that looks like, render that. Okay, and then file, export as SVG. So V2ER, V2ER.svg. Okay. And let's kind of steal this. And let's close this. Let's open this one. So open this in the editor as well as in the viewer. Let's paste this. Instead of V2ER, it's IS. And then let's zoom extents. Let's render it. Let's say, hey, that looks good. File, export as SVG. And this is V2IS.svg. Okay, let's copy this. Let's close this. Let's open the next thing, right? So here's the last thing we want to work on. Let's, we got too many things open here. So open with, paste this here, and then instead of V2IS, it's ES. So instead of interior, it's exterior. Okay, so now that we have this, we're going to file export as an SVG. And V2ES.svg is kind of what we're going to call it. Okay. And now we have, like, all the source files. We have all the source files that we need. And we're going to have to process them in paint.net to, like, really get something ready, right? So one of my worries here, so if we go and we try to open this, let's just open it with Inkscape. So the rectangle. So this is the rectangle. So my worry here is that when we open this, we're going to have a problem, which is that the entire canvas isn't going to show up, right? When we export, the export has no idea of how big things are. I don't think it does. Okay, so we're kind of lucky with this because the bounds just worked like that. And if you look at document properties, right, we should be able to see that if we go into units of inches, we see exactly 12 by 12. So that's awesome. Only problem is that I guarantee we're not as lucky when we open up, if we open up the, close without saving. If we open up the square, I'm going to guess the square isn't going to be as lucky. So let's go open up the square and see what's up with that. So let's just open up the square, open with Inkscape, right? if we open with Inkscape, like I said, when we export, it doesn't really know what the bounds of everything are, right? So it just snaps the bounds. And sometimes it's a good thing, and then other times it's just it's a horrible, horrible thing. So our problem here is that, right? This is not aligned, right? So how are we gonna align this? I think that we have some alignment tools. So I think there's like alignment. Yeah, align and distribute. Align and distribute. Gotta hit the high contrast. The high contrast settings for Windows, like, no application properly supports it, so it's like if you don't properly support it, then why even try to support it? Like no support for high contrast is better than this half-ass support where I can't even read. Like, I literally can't read what that is. It's just like a little black bar. Like, that annoys the heck out of me. So I don't even know what these alignments are. I know that there was one is centered, and I'm gonna guess that this kind of like goes up to the edges, and so maybe we can use these alignment tools to figure out what we need to do. So let's go File and open the other, I don't even know why it's like, I just opened this file. Why are we in here, right? Like, why the hell aren't we in the actual folder that I was working in? So that's annoying me. So inside our repo drive, right, inside of Git, we have the upat folder, right? And then we have the models, and then we have duct tape box, which is what we're working on. And we have the cut folders, and right now we're looking at the interior. It looks like an interior. Yep, interior, it's a square. So we want an interior of a rectangle. So let's open this up. And what I'm thinking is we can take the... Come on. Inkscape does not work very well with multiple monitors. So I'm thinking we can take this and we can... I really hate how new opens up like a new application, and that new application may not like... Okay, so we're going to take this and say File, Document Properties, and we're going to use inches, and we're going to change everything to 12 by 12, right? We're going to change this to 12 by 12 exactly. And we'll close this. Yeah? Yeah, we'll close this. And now that you have a 12 by 12, we're going to just take this Control-A, copy, and then edit. We should be able to paste it in place, and everything should be kind of like where it's supposed to be. That actually worked better than I thought it would. I thought the origin would be somewhere else. Okay, I think we just lucked out. We don't even have to do any alignment. Okay, we lucked out. We lucked out, everybody. We lucked out. So we can take this, Control-A, Control-Copy, and we can go Edit, paste in place. Bam! Yeah, we just got lucky. We just got lucky, but that's cool. I'll take it. I'll take the luck. So now we have kind of like both files composited correctly, right? So this is literally just the interiors, right? So we're going to File, and we're going to Save As. And once again, not the correct folder. Models, duct tape box. It's also the thing I don't like about this is give me a folder selector that lets me type the file path in there, because it does not work for my shortcut script. Or if you knew the exact folder name, you can't just type it in there. You have to do this stupid selection thing. It really slows down my workflow when I have this kind of stuff. So we're going to call this, technically this is v2 exterior, right? v2 exterior dot svg. Okay, so it's just a composite of those two files, right? The square, it has the square and rectangle in them, and it's the exteriors. So now we need to go to fill in stroke here, and we need to change some settings for the laser cutter. Now this may differ depending on how your laser cutter works, but for an epilogue laser cutter, we need to select all this, and we have to go into the stroke, or sorry, my bad. We have to go into the stroke style. We just have to set it to, usually what I do is pixels, and I do 0.001 pixels. Now, that could be wrong. It just needs to be small enough. Once it hits a certain small enough size, then it creates cuttable lines. So, we're going to do that. And then for the fill, I think if we did a fill of nothing, we'll have a problem because the lines are so thin that we just won't see anything. So let's not do that. Let's instead just, I can kind of see some... Actually, let's not do that. So I noticed that sometimes if I change the colors of things, it gets hard to... right, I can see the border here. I think that's fine. But if you change the... Sometimes if you change the colors of things, you get these files that just won't print at all. And I have no clue why that is. So I want to avoid that. So we're going to save it like this. And we're going to file, and we're going to export. So we're going to... I'm going to go up here for a second. I don't know where this is going to end up saving. So file... Actually, no. Let's just go down here for a second. And let's just black out the screen for a different. Here. And it looks like my software might crash on me. So that's all good. Let's close this. Close without saving. Okay. So now in here, we already took these files and put them together, right? So let's close this and let's file open. We want to open the exterior, right? So open the exterior that has the like logo and stuff. Let's close this now. And we need to move it over to this monitor because Inkscape doesn't work very well for multiple monitors. And we can see like now we have this logo, right? I got the logo kind of emblazoned there. Well, let's go file open. And let's find the square that's the exterior. So square exterior, so let's open that up. And once again, it's on the wrong monitor. It's like halfway on the monitor, so I can't even grab the tab. It's annoying. I can't even show you what the annoying thing is, but... Okay, so now we're gonna do a file new. And we're gonna say document properties, and we're gonna make it exactly 12 by 12, right? So we're gonna go... inches, and say 12 by 12. So I believe the way we got this to work coincidentally the first time was we just pasted in place. So let's just take this whole thing here, Control A. Then over here we're just going to go, I believe it's edit paste in place. Yeah, edit paste in place. Bam, it's right down where I want it. Probably because the way this software works, it probably thinks the origin is down here. Probably thinks the origins are bottom left. I'm used to origins up at the top right, that's why I did not expect this to work. Okay, so now we'll take this thing here, and we'll Control A, Control Copy. Then we'll go over here, and we'll go Edit, Paste in Place. And everything's nice and lined up there. So now we'll just go into the fill and stroke again. And we'll change the fill and stroke so that everything is thin enough that it can be registered as a cutting path on the laser cutter, right? That's what we're trying to do here. And I don't know why I can't make this any thinner. Like, I can't grab this and move it. Okay, so we'll take this and stroke style. We're gonna go to pixels, and we're just gonna set it to, you know, 0.001, and that should be small enough. And then we're just going to File, Save As. And right here, this V2E for exterior. This is going to be V2E, V2I for interior. And we may have that actually backwards. We have that backwards. Okay, whatever. We'll flip the names around after, but v2i.svg. Save that. And then File, Save As, and save this as a PDF. Okay, so v2i.pdf, save, okay. So now let's close this, close without saving. One thing that's we've kind of lucked out with, because Inkscape, because Inkscape is kind of stupid with how it names files. It has .svg.svg, we got pdf.pdf, we got svg.svg, pdf.pdf. That makes it a little bit easier to rename the files to the correct names, right? Because we swapped what we thought was the exterior and interior, we got that completely backwards, right? So, yeah, so in a PDF viewer, we can confirm that these paths look good to me, right? They look great. But this should be the exterior file, not the interior file. So we're just gonna rename things, right? We can just take all these things and say 1, 2, 3, 4. We got these 4 things. Let's just rename them. So rename, right? So while we're changing the extension here, we can also change. We can just flip E's to I's and I's to E. So v2i.svg, right? Because that was originally an E. Then let's change the complementary one back. So rename this to v2i.pdf. And then these are going to be our E's. So go over here, rename this to v2e.svg. And then we're going to rename this one to a v2e.pdf. And right, let's open up both of these. So I'm going to open up this one, I'm going to open up that one, and I'm going to make sure they look correct. So there we go. Right, so we got this here, we got that here, right? So exactly on a 12 by 12 for creating a crate for the product that we want to sell. Now, the product we want to sell is the acrylic squares are 10 by 10, which is a little bit undersized for what people are probably expecting. So I don't know if that's going to hurt us. But the name of our company is DEKTEN, which so it has the letter number 10 in the name. So by selling 10 by 10 sheets, right, then maybe maybe that'll help us. I don't know. So I'm gonna put these on the other monitor. Actually, no, I'm just gonna close this PDF reader, close all tabs, and we have everything we need to give it a shot to like cut this stuff tomorrow. If we want to give it a shot tomorrow, we can. We're ready for that if we need to. If we want to try it out. So the only other things that we could do for optimizations are make paths that we can try to cut on both sides of the wood, right? So sometimes getting through that last bit of wood is very difficult. And if you can cut halfway through on one side of the wood, flip the wood over, and then cut on the other half of the wood, you can really speed things up. The only problem with that is to get to pick up the wood and flip it over and get it to be perfectly aligned after you've picked it up and put it back down in the laser cutter is very difficult. I have some tricks for that to make it feasible, but it's still very tricky and you have to put a lot of effort into figuring out how to do it. It's not just, hey, let me eyeball it and make sure it still lines up, right? Like, you gotta be on top of your stuff, right? Like one thing you could do is, you know, if you have a completely symmetrical design and your piece of wood is exactly 12 by 12, exactly 12 by 12. If you're off by just a 16th because, you know, you have some kerf issues when you cut the wood, it's not going to work. So the best way, if you want to cut something on both sides, is to put a piece of wood square up against the sides of the laser cutter bed and have a tool path to cut a big square into the wood first before you cut anything else. And cut that big square so that you can take that square out of the wood, flip it over, and put it back in. And that big square that you cut out will be perfectly aligned because you just cut it on the laser cutter. And then you don't have to worry about moving a slab of wood that isn't exactly cut to specifications. I find that works pretty well. There's still a few problems with that because you have some inaccuracies due to the kerf, and so things can still wiggle around a bit and not be completely accurate, but it works pretty well. We're not going to do that. We're just going to cut all the way through, and if it doesn't, if it splinters a little bit, we're not going to worry about it. If this is supposed to be a box to protect the product. So if there's minor defects on the box, that's okay. I really care mostly that it's going to protect the product, so I'll leave it at that. But yeah, so we have... is it the weekend? It's the weekend, so I used to go clubbing on the weekend, and that's a reminder to message some people. Yeah, so it's almost 9, and 9 is when I need to take drugs, so... I'm going to commit this stuff because now I have something ready to cut for the laser cutter. And also, we need to make sure that the index is updated as well. So let's make sure the index is updated. So we made a little index in the models folder that was going to help us keep track of, like, everything. It looks like we already have the index updated. So, like, over here... right, the last thing we worked on was this duct tape box, right? Okay, so that's good. I'm hoping that, right, this box is going to exactly adhere to the material we're packaging, right? So we're kind of like tightly packing the material. We're hoping that the wood will shield the acrylic from being shattered in transit, right? So we're hoping if we put this wood around the acrylic in this box is nice and sturdy and duct taped together, that it won't get damaged in transit. And then we're also hoping that by making this box kind of like very tight to the dimensions of the acrylic, that the box isn't that big and the shipping costs will be reduced because it's under 12 inches in size. So we're banking on some things. I don't know exactly. We'll see, right? We'll see how well this works. We could perhaps have some problems due to things being slightly off due to kerf. And that'll suck, because if it's off from the kerf... God damn it, yeah. Okay, we can fix that. Actually, we should probably fix... Oh, God, that means we have to fix a whole bunch of stuff, don't we? Kerf. Everything fits together so nicely, but... Damn it. Okay, so we're not ready to cut this yet. Not ready to cut. need kerf adjustment because the model is to fit snug to the material being shipped. So we're not ready to do this yet. It's like, yeah, we got something kind of ready. We got something kind of ready, and all that work we just did is kind of down the drain now that I realize it. So, so that sucks, but it's not ready. It's not ready at all. So let's go to the so duct tape box. The duct tape box. Let's go in here for a second. Let's go into the cut folder. And once again, god damn. Well, we'll get used to this, but yeah, the kerf, because the material is exactly 10 by 10, if the wood is cut to have an exactly 10 by 10 interior surface, that kerf is going to okay, before we nuke these files, we might as well, it's V2, right? It's called V2 for a reason. Let's just call it V2, see if it works, but it might be, we might have to do kerf adjustments to get this to work. We may be better off actually using scrap material for the edges of the box, because the kerf adjustments mean we're going to have to change things around anyways. So I'm thinking, we use scrap acrylic for the edges of the box and wood for the top and bottom, and then the scrap acrylic can be used by the client for test cuts, right? So sides of the crate are made out of scrap acrylic so that you can test out cuts, right? And then we don't try to make some type of scrap sheet of acrylic, right? We just put like 9 sheets of acrylic in it or something, or we put 10 sheets of acrylic. Yeah. So okay. Okay, yeah. Let's just save this for now. Let's try to cut it and just see what happens, and then let's see what happens. We can assess it. To back off of the kerf problem, what we could do to fix that is we could add, we could painstakingly put like a little bit of we could get like a paper towel. We could get paper towel, and we could, on the joints, we could put paper towel between the joints, and that could help. If we put paper towel between the joints, it would help, we would have to very meticulously put it between the joints, though. It would be a very meticulous process. So yeah, kerf is going to create a problem there. Oh, God. Kerf is going to create a big problem. I'd say Kerf is going to create a problem. Too much of a problem. Let's just call this, let's put this in V2 and just say, you know what, I'm not confident. We can keep this, we can keep these here anyways. Right, let's not throw them out. Sure, let's keep them. But we're never going to cut these. I don't think we're ever going to cut these, but let's not nuke these. I think they're nice files, but I just, yeah, the kerf is going to create too much. Okay, so what do I mean by the kerf is creating problems, right? Like, you're looking at me and you're probably like, what the heck are you talking about? So... Oh, and if we move these inside of here, then all the nesting is wrong. So, can we just go open these? No. Okay, if we're gonna nest them a bit deeper, though, we have to... Let's open these. We have to include... Our includes all have to go back twice like that. Right? Because these are relative includes. Sure. I mean, we can do that. Sure, why not? And... if we do that, we can open up, let's open up the square for a second. Let's open up the square, exterior square, and so I can tell you what I mean. What am I talking about where we're going to have problems because of kerf? Well, the problem is that this square right here is the area where we're going to lay the product is exactly 10 by 10, right? There's no there's no wiggle room. And there's no wiggle room for this 10 by 10. Sorry. I'm thinking here. Too many text files open. Okay, so dtp.scad, right? So if we look at some of these variables we have, some non-standard constants, and we have the box span. And we notice that we have sheet span in inches, right? Sheet span in inches is 10, right? The sheets are 10 by 10, right? And we're holding 10 of sheets currently. And that means that from this little red line right here to this red line here is exactly 10 inches. But that means if we're going to lose material due to laser cutting on this edge exactly, and lose some material by laser cutting on this edge exactly, that means in the end, the area of this is going to be less than 10 by 10. Which creates a problem, because if the box is slightly... if the box is slightly too small for the product, we're going to have a problem. And I know that my sheets of acrylic are exactly 10 by 10. So if this is anything under 10 by 10, then this box is not going to be able to hold the product. So what we could do is we could put like a... To reduce the problem from the kerf, we could put a little bit of like tissue paper here, and then over here, and 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 all over there, and then we could make it work, right? But then if we do that, the problem is that if we do that, the problem is that's just difficult, where it takes a lot of time to meticulously do that. So We could just try to do it. We could just try it and see how well it fits together and see if it's acceptable, right? So we don't know if it's going to be acceptable or not until we give it a shot. And this is the basic design I want. This is the cheapest way we can do it. I mean, it's still an expensive way to do some product packaging, but we want to differentiate ourselves, right? The idea is we want to try to differentiate ourselves and make some type of high-quality product packaging for what we're selling, right? So even though the cost to us is very expensive for this package, right? Like it's like $3.75 just for the product packaging. How are we going to stand out from other people who are already selling acrylic that have already been doing it for years, right? Like, I got this acrylic many years ago, and I'm just finally figuring out how to sell it, or finally getting around to getting ready to sell it, so might as well kind of just cut this and see what happens. But the first priority is to work on a table, so I think I'm not going to try to cut this right now because we don't want to waste material. Right now, R&D is kind of expensive. We don't want to waste material unless we're absolutely certain about how we want to go about this. So I am leaning towards cutting this, but kind of taking this edge right here and just moving it up a little bit by the kerf. So we move this edge to the left, however much the kerf is, right? So if the kerf is a 1/16 of an inch, then we move this line a 1/16 to the inch this way, right? And then this line goes to the right a 1/16 of an inch. I'm thinking we cut this out of wood, and then we cut for the sides. We just cut acrylic pieces. We cut acrylic pieces that that will help. So what we could do is we could make these insets. We could just bring these insets in by... Actually, I like that better. We could bring these insets in by 1/8 of an inch, all of them. And then we... After the insets are brought in by a 1/8 of an inch, so so these grooves are 1/4 of an inch deep. We bring them in by 1/8 of an inch, and we use scrap material on each of these edges to to seal it off. But then on the inside, we have a little bit of room to contiguously what do you say? We have some room to pad it with some tissue paper, like a very thin layer of tissue paper, right? And maybe not bring it in 1/8, right? Maybe bring it even less. Right, so if we move this out less, like 1/8, we just want to move it out enough to where we'd have to experiment, but I guess start out with just moving it over 1/8. And then we can put like one layer of 1/8 inch acrylic for the sides here, and then we can duct tape it here, here, and then up and down here like this, bam and bam. And right, so duct tape from here to here, duct tape from here to here, duct tape from here to here. Use kind of like thin strips of duct tape. And then after we've duct taped across here, we duct tape each of these sides nicely. And so this side will have kind of like a air gap. I don't know. We just need to make sure the package is strong enough for protecting our shipment, right? So I think, and we also want this box to We want the box to be like, oh, it's high quality because it comes in a crate, it doesn't come in cardboard. But we also don't want the user of the product to get mistakenly think that it's a container that you're supposed to reuse, right? Because if it gets damaged in transit, right? Like, you don't complain when, oh, the cardboard box that my product came in got got dented, right? You don't complain if that happens, right? So it's the same thing as this. This is actually just a fancy shipping container, right? If the shipping container gets slightly dented up, you don't care as long as the product in it is okay. So we need to make sure that this is a shipping crate, right? So we may want to actually say DEKTEN shipping crate, right? We might want to actually, instead of just putting our logo, we might want to stencil shipping crate on it, right? So, or shipping, right? Shipping crate, so that people don't think it's supposed to be some type of reusable thing, right? Because they think it's a throwaway thing, but it's a very expensive throwaway thing. You know how, like, there's plastic throwaway silverware, but then there's, like, the plastic throwaway silverware that's like painted metallic, so it looks fancier, and so it costs more than the other throwaway silverware, but it's still throwaway. So the idea is that this is a throwaway or a piece of scrap material. Once you got the product, you can do whatever you want with it, but you shouldn't feel bad that it's been damaged, right? So I think over here we should probably kind of fix that up and say, so so you know what? I'm just gonna get rid of V2. Now that I've given a lot of thought, and I think that, yeah, we did a lot of work on this, and sunk costs, blah, 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 whatever. But we don't have to... Okay, no, we'll keep V2, but we're never gonna cut V2. But I'm on the verge of just nuking it completely. So let's go into the main file here for a second. And we know that we have some edits. I have to go upstairs really quick, take some drugs. I'm going to take a quick break. And then I'm also going to do the rest of my push-ups, because I think I only need like 10 more, or 20 more. I'll do like 20 more. And then if that's a little bit more than I needed, that's fine. But let's just do a break. And let's give it like 12 minutes. We're still kind of working on this. I opened up the main file, and I think that we need to change. So logo square, logo rectangle is what we did. So let's take one of these things that was commented out, right? Let's take some of this commented out stuff, and let's run one of these things. And I think on here, for the square, we want to just say, hey, shipping crate. And then, I don't think we have lowercase letters. Yeah, I don't think we actually have lowercase letters, so... Hey, how's it going? I'm, working on some, like, 3D models for, like, a crate for, like, shipping products. Yeah, and then I'm probably gonna get... I'm pretty close to, like, finishing up, but, I just want to get stuff, I just want to get stuff going. I don't know, I want to get to a good stopping point. I'm almost at a good stopping point. But, I just realized that if I put my product... So this is, this has to do with, I have a whole bunch of acrylic. I bought, like, 3 tons of acrylic a while ago to work on prototyping some inventions. And, now I have a whole bunch of acrylic and I want to sell it on, like, Amazon or Etsy. And I'm thinking, well, how do I differentiate myself from other people who are also selling acrylic? And I'm like, well, let's put it in a very nice packaging, right? Okay, well, if we put the acrylic into a wooden crate and we ship it that way, one of the problems is somebody could get that wooden crate and the wooden crate could be damaged. And then they're going to think that the product is damaged. Or not, they're not going to think they're going to think the crate is actually the product, right? Or part of the product. Like, if you ship a box with something that somebody bought on Amazon, and that box gets dented up and scuffed up, you don't complain. You go, oh my god, my box is dented. Oh, everything inside is fine, but the box is dented. 0 out of 5 stars, right? You don't do that. However, we risk, with making a crate like this, making a very fancy crate to ship stuff in, we risk people thinking that the crate is like some type of reusable container that is part of the product itself. So we don't want them to think that. So we're thinking that one band-aid we could put over that is just, you know, we could label it as a shipping crate, right? DEKTEN shipping crate. We could label it as a shipping crate, and that's what I'm kind of doing. And I'm going to read what you're saying just once I get this moved up a little bit here. LX, LY, LY 0, -2, and everything is crazy. So yeah, so it's something like a DEKTEN shipping crate, like just calling it a shipping crate, so that way when somebody gets the product, they don't think that it's a reusable container. We just put shipping on it. Maybe we should probably spell shipping correctly with like 2 P's. Yeah. So I'm working on my first show. My idea is to make a show where the odd numbers of episodes are animations and the even numbers of episodes are games. Yeah, I mean, I definitely do things like that as well. Like, well, not with what I'm doing, but, with, like, schedules, you know, like, it's sometimes hard to keep to a schedule, and sometimes you need to do, like, when I was doing a lot of coding and art, I was thinking, oh, you could have, the odd days would be code days, and the even days would be art days, so I've definitely done something like what you're talking about. I haven't done it on a stream, I've just done it as a work habit, because I find, sometimes, I have these 2 projects, and honestly, whichever project I pick up and start working on for the day, The other one just doesn't get any attention, is what I usually find. So doing it where you do dedicate one day to one thing is probably a good way to go, because you wake up, right? You wake up and your mind's kind of blank, and then you start loading context into your brain when you wake up, right? It's going to be a show like a meta runner. I'm not familiar with what a meta runner is. So let me go look that up for a second. Meta runner. Is this what you're talking about? I haven't actually seen this. Honestly don't have too much time for cartoons, but I could check it out and see what that's all about. Esports, hard reset, Wikipedia. Let's see what Wikipedia says. Uh-huh. Okay, I got it. It reminds me of like a really old cartoon. Was that really old cartoon that nobody watches anymore that had like an enemy called Gigabyte? Oh, Reboot. Reboot cartoon. So you probably don't know what this is, but right, 1994, there used to be this like old cartoon where I don't know. That's the initial vibe I get from what I'm seeing there. It has 2 seasons. All right. Well, here's what I'll do. When I forget, next time I'm like not feeling like working and just looking for something to watch on the internet, I'll go look that up. Watch 1, 2, 3. Runner. Go find it. So I'll just make a note that if I'm looking for something, because sometimes it's hard to figure out what to, when you're bored. When you're bored, the first thing that's kind of hard to do is just find something to entertain yourself, and then you spend like hours just looking for something decent to watch. So I can put that on, right? So watch 1, 2, 3 is kind of like the little tag I put on like random pieces of entertainment I want to watch. So I'll just put that tag in there, and next time I go search through my shortcuts for something to watch, I'll stumble upon that, be able to find it, and see what that's all about. Yeah, let me put this back up here. So yeah, I mean, as far as like working on ideas, I would just, I just go for it. Like, if you have an idea, just try to execute it, and don't worry too much about like if it's not going to be perfect. Just do it, you know. Because I mean, things will polish, things will get better, as you just do it more and more. I mean, like all cartoons that you watch have that kind of thing in common, where the older episodes don't look as polished as the newer episodes. That just happens. Shipping crate. Is that how I spell shipping? Yeah, I think that's... Yeah, okay, I got that spelled right. Okay. Yeah, so I'm gonna commit what I have, and then I think I'm just gonna get out of here, because, like, I'm just tired of this. Also, let me check my schedule for Maker Work, so... Okay. So let's go... This folder right here. Let's go to the root folder, git bash here. We're just going to commit the code we have for this stuff. Um, okay, yeah. So I'm pushing that up, and yeah, I'm about out of here because, um, yeah, it's like 9:38 here, and there's some other things I want to do, like research some things. For example, I tore my bicep tendon a while ago from doing crazy stuff, and it still doesn't look normal. It seems like it's kind of functional, except when I lift really heavy stuff, I can feel it kind of wanting to give out, and I want to research more on that and see if I need surgery or what I got to do about that. So I'm out of here. I'm out. Yeah. So good night.